All right, we have a Ferris wheel problem. Ferris wheel problems are very popular for math teachers. Okay. Ferris wheels show a nice practical example of sine and cosine functions describing circular motion. So our particular Ferris wheel is 5 meters above the ground, diameter is 26, and it does a full rotation every 9 minutes. So we want to know how many minutes are spent above 23 meters. All right. Probably know I like illustrations. Here's our Ferris wheel. We're going to be interested in the maximum, the midline, and the minimum. Okay, we're going to use a sine function. And let's just pause here because you could use cosine as well. You could do a phase shift on the sine function. I'm deciding to start my guy here, which may be unrealistic, but for the purpose of this problem, it doesn't matter. All we want to know is, in a full circle, how much time is spent above 23 meters. Okay. If you wanted to start them here down at the bottom, you could do a phase shift of the sine curve, or you could use a negative cosine. And it's worth thinking about why all these things work and how they're related. Okay, we're just using a basic sine function. And so what we need are these values, A, B, and C. A is the amplitude, B is the frequency, and C is the midline. Okay, now let's just take a look at, okay, as this guy rotates, we want to think about these three values, and they should be fairly clear. And just notice how the sine function describes this motion. Here we are at the minimum. So it's a function of time. All right. So the maximum is 31, the midpoint is 18, and the minimum is 5. Okay. Again, just to reinforce this, circular motion described by the sine function. Okay. Good. So here is the function. So 13 is the radius, or you can think of it, it's the distance from the midline to the maximum. The frequency is 2 pi divided by the period. The period is 9 minutes. It takes 9 minutes to finish a full circle. The midline is 5 plus the radius. Also think of it as the vertical shift. All right. So now what we're interested in is the amount of time that it's above 23. So this section here. So I need this point and this point. I need to get those 2 times, and the total will be the difference. So we're going to solve this equation when the function equals 23. That's these 2 points. Okay. So I recommend you go through this on paper. We're just solving the equation, pretty straightforward. Bear in mind that when you put this in your calculator, you will only get one answer. So we have to get the second answer. Okay. So you put that in your calculator, and we get around about a little more than half a minute, right? Okay, so that's the first point. Okay, now the second one, let's think about the second one. First one is there. The second one is here. Okay. So the second one is this much time, 0.566, short of a half rotation. Okay. So it does a half rotation in 4.5 minutes. Okay. So we're this much short of 4.5 minutes. Now we have our 2 times. We should be good. We just get the difference of those, and that's our total, above 23. All right. So, like I said, Ferris wheels, very popular way to show trig functions in real life. Yeah. And take some time to think about what phase shifts do to the Ferris wheel, what changing to the cosine does. It's basically changing the starting point of the guy. That's what those things will do. All right. 3.37 minutes. I hope that was helpful.